For data sets having a distribution that is approximately normal or bell-shaped, we have the following properties. About 68% of all data will lie within one standard deviation above or below the mean. That's what the positive negative means, above or below. About 95% of all data will lie within two standard deviations, and that was the justification for the range rule of thumb. And about 99.7% of all data will lie within three standard deviations above or below the mean. Now, the text that we use introduces the empirical rule before the z-score. I have introduced the z-score already so that we can use the z-score to help us determine which set of data we have, the 68, 95, or 99.7. And those three values you do need to know that 68% is for one standard deviation, 95 for two, and 99.7 for three. So we have a picture here that represents the empirical rule on a normal distribution. This is for a sample mean of x bar and population sigma, population standard deviation sigma. So your x bar, your mean, is always going to be in the center. And then just like you would put 1, 2, 3 on the number line above and -1, -2, -3 below 0, well, we have our standard deviations of positive 1 sigma, positive 2 sigma, positive 3 sigma, and then the negatives on the other side. Now within one standard deviation, we have 68% of the data values. Within two standard deviations, so that's everything shaded in blue, we have 95% of the data values. And then within three standard deviations, so I'm going to shade over that in black, we have 99.7%. So outside of three standard deviations is the other 0.3%, and since this is symmetric, half of that would fall on one side and half on the other. Keep in mind, normal distribution is symmetric, and we can at times use that symmetry to help us find answers to the questions that were asked. So to find the percentage of values that lie between two data values, first find the z-score of all given data values, and then interpret those results using your empirical rule. So we have IQ scores that are bell-shaped with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? So first step is to find two different z-scores, one for each data value that you're given. And here we have a mean of 100 and a standard deviation of 15. Our data values are 70 and 130. So data value minus the mean divided by the standard deviation, data value minus the mean divided by the standard deviation. So for the first one, we get a -2, and for the second one, we get 2. So that tells us, here's our mean, that we are at the -2 standard deviations and +2 standard deviations. Well, within one standard deviation, it was 68. Within two standard deviations, we have 95%. So our second step is to finish answering the question, what percentage of IQ scores are between 70 and 130? Well, 95% of IQ scores are between 70 and 130. Okay, another example, we still have the IQ scores that have a bell-shaped distribution with a mean of 100 and standard deviation of 15. What percentage of IQ scores are between 85 and 115? So again, our first step is to find the z-score for your individual data values. So 85 minus 100 divided by the standard deviation, and 115, which was your other data value, minus 100 divided by the standard deviation. So, for the first one, we get a negative 1, and for the second one, we get 1. That means if our mean is in the center, we're at negative 1 sigma and positive 1 sigma. And between one standard deviation above and below the mean, there's 68% according to the empirical rule. Therefore, our last step is to say what percentage of IQ scores are between 85 and 115, and that is 68%.